let f be a function that is continuous on the closed interval 2, 4, with f of 2 equals 10 and f of 4 equals 20. Which of the following is guaranteed by the intermediate value theorem? So let's draw a little plot of what's happening. We'll have x, the x-axis, and y here. So we have the point 4, 2, or 2, 4, an x value of 2 and a y value of 10. And at an x value of 4, we have a y value of 20. So on this region, we need to find out which one of these statements is guaranteed by the intermediate value theorem. So what the intermediate value theorem says is that in the region between two x values for a continuous function, between the y value of the first point and the y value of the second point, every single y value can be found on the function between those 2 points. Meaning that the intermediate value theorem says that in this case, from x equals 2 to x equals 4, the y values are y equals 10 and y equals 20 in this range. So what IVT guarantees is that the graph of f of x goes through all of the y values from 10 to 20, meaning every single y value from 10 to 20 has to be located somewhere on this curve. That no matter how we draw this curve from 10 to 20, all of the y values will be somehow touched by the curve here. And it doesn't matter how we draw the curve. So here I've drawn a random curve between 2 and 4. We could have easily just made it a straight continuous line. And we see that every y value would still be located on the curve between 10 and 20. Or we could have made it a sort of exponential function like this, or even like a parabola like this. Any kind of continuous graph that goes from a y value of 10 to a y value of 20 will have to also go through every single y value in between. So that's what the IV intermediate value theorem guarantees. So let's go through these answer choices and see which one of these confirms this. So A says f of x equals 13 has at least one solution in the open interval 2, 4. So this is true because f of x equals 13, so that's saying a y value of 13, has a solution in the interval from 2 to 4, meaning there is some x value somewhere in this interval from 2 to 4 that has a y value of 13. And that's true because when we go from 2 to 4, our y values go from 10 to 20, which means we also have to go through a y value of 13. So there is some x in here that has a y value of 13. So the equation f of x equals 13, f of x we will just write as y because that's what we made it in this case, does have one solution. So A is true, but let's check the rest. B says f of 3 equals 15. This is not necessarily true because the intermediate value theorem doesn't tell us anything about the points inside, like the actual specific locations of the points on the graph. We don't know if f of 3 equals 15. Like this, if we don't know if the graph goes through 15 at an x value of 3. So the graph could look something like this and pass through 15 somewhere much closer to 4. So this doesn't necessarily have to be true. So B is not correct. F attains a maximum on the open interval 2, 4. So this is not necessarily true because the graph of f of x could look something like this, and outside the graph, it could just keep increasing here. The intermediate value theorem doesn't tell us anything about the maximum of the graph of f of x. It only tells us about the y values between the intervals where it started and ended. The graph f of x could still continue going on, so there doesn't necessarily have to be a maximum in that interval between 2 and 4. F prime of x equals 5 has at least one solution in the open interval. This is not necessarily true. We could have a piecewise function between 2 and 4, where this could be like some slope and this could be some other slope between the values. So we don't necessarily have to have a slope of 5, because f prime equals 5 means that the slope at some point in this curve between 2 and 4, we don't know what the curve looks like, but we can't say for sure that there's a slope with 5 at some point, because there could just be a piecewise function between these two, and they could have slopes that are not equal to 5. So D is not correct. F prime of x is greater than 0 for all x in the open interval. This is not true, because so f prime of x greater than 0 just means that the function has positive slopes, or that the function is always increasing. They're both saying the same thing. But we could draw any graph between 2 and 4. We could draw it something like this. Here in this initial region, we have negative slopes because our function is decreasing. The y values are going down. But in the end, all that matters is we're still getting from 210 to 420 between these 2 points. So no, we don't need to have a positive derivative for all x between these 2 points. So A is the correct answer.